All right, welcome everybody. Hononegah Honors Algebra 2. We're going to start off this year with what's known as the P chapter or the pre-chapter, basically working on some of your algebra skills. Obviously, we haven't been to school in a while for some of you, and so just preparing ourselves to get into the book. So an equation is the first thing we're going to talk about. A mathematical sentence stating the two mathematical expressions are equal is called an equation. An equation basically must have an equal sign. So one side must equal the other side. So to solve an equation means to find the value of the variable that makes the mathematical sentence true. So you're finding the value of, let's say, x or y. Some equations have more than one variable, and sometimes we have to solve equations with more than one variable, but ultimately solve an equation for a particular variable. So we're going to solve this next one. We want to isolate the variable, meaning we want to get the variable by itself. So you want to do inverse operations, meaning if I add, whoops, I'm going to move this down here then. I'm going to, if it's a plus 7, I'm going to subtract 7 from both sides. And remember, anytime you're dealing with equations, you must stay balanced. So what you do to one side of the equation, you must do to the other side of the equation. We will deal with that a lot in this class. So a lot of times when we're dealing with an equation and you want to solve it, sometimes you have to do the inverse operation to balance out the equation. You'll have to do it to both sides. So the next, I'm going to multiply both sides by 3. That will get rid of the bottom, or the denominator. And then I'm going to divide both sides by -2. So x is equal to -12, meaning if I plug -12 into the original equation, it would be balanced, meaning one side would equal the other side. Getting a little bit more in depth, now we have a variable on both sides. So you always want to get the variable on the same side. So subtracting 3x from both sides, subtracting 6, and dividing by 7. So fractions. Now let's talk a little bit about fractions in this class. Leave your fractions as improper fractions. You do not have to turn them into mixed numbers, nor do you need to turn anything into a decimal. If you do turn it into a decimal, I will not count it wrong, but ultimately it is better to leave it as an improper fraction. So -15/7. Next one, more steps. All that's happening in mathematics, the older you get and the more you start dealing with Algebra 2, you start dealing with trig pre-calc, you start dealing with calculus, everything just requires more steps. So I'm going to distribute. So I'm going to multiply to everything that is inside the parenthesis. Then I'm going to add like terms on the same side. So -8x and 13x I can add together. -24 and +7. I can add together. Now, there's going to be a little bit of an issue here. I'm going to use a different color. I'm going to subtract 5x. If ever you get a situation in which the variable is no longer in the equation, so you did inverse operations and the variable is gone, this will always be an all or nothing, meaning it's an infinite number of solutions, infinitely many solutions, or all real numbers is a solution, or no solution. Well, since -17 does not equal -19, this would be no solution. The symbol for no solution is a circle with a line through it. So no solution. So anytime you deal with a word problem, and I know some of you are going to cringe when I say word problem, so just be patient here. Explore the problem, basically that means read it, and define the variable, meaning what are you trying to solve for. Then plan for the solution, basically meaning write an equation. Then solve the problem, meaning solve the equation. And then last, examine your solution, and does your solution make sense? So when you're doing a word problem, read it, define a variable, meaning what am I solving for, write an equation, and solve it. So here we go. The Hernandez family spent $357 on a one-week rental car in California. The rental fee was $285, insurance was $38, and they paid 5 cents per mile. How many miles did they drive? So what is our x? What is our variable? We're looking for miles. And so since they spent 5 cents for every mile, plus $38 for insurance, plus $285 as a rental fee, and the total cost of their trip was $357. So again, establish your variable. What are you trying to solve for? Write an equation, and now actually solve that equation. So add like terms. Anytime you have two items on the same side of the equation that are alike, you can add them together. So 38 plus 285 is 323. Subtract 323 from both sides and get 34. Divide by 0.05 and you get 680 miles. Bubba's sister is 3 years older than half his age. His mom is 2 years older than 3 times his sister's age. If the sum of their ages is 86, then what is each of their ages individually? So again, we have 3 different people here. We've got Bubba, we got Bubba's sister, and we got Bubba's mom. So now, let's talk about Bubba first. Here's Bubba. I'll even draw a little picture for Bubba. Okay? He's got a spiked haircut. So now, Bubba we'll call X. So now, Bubba's sister. Okay? We'll even draw a little stick figure. Bubba's sister. Okay? Bubba's sister is 3 years older than half his age. So half Bubba plus 3. His mom, Bubba's mom. I don't know how we're going to make a picture of Bubba's mom that's different than Sis. So maybe she's got curlier hair. So now, Bubba's mom is 2 years older than 3 times the sister's age. So 3 times the sister's age, so there's, and 2 years older than that. So we got Bubba, who's X, Bubba's sister, which is half X plus 3, and mom, which is 3 times the sister's age plus 2. The sum of their ages. So if I take all of them and add them up, so Bubba plus Sis plus mom adds up to 86. Now, there's a lot of fractions here, a lot of distributing here, but here we go. X plus a half X plus 3 plus 3 halves X plus 9 plus 2 equals 86. Adding that up, so 1X plus a half X plus 3 halves X, it makes 3X. So that's these. 3 plus 9 plus 2 adds up to 14. Subtract 14 and divide by 3. So X is equal to 24. So now, what is each of their ages individually? Well, Bubba, who was X, is 24. So Bubba is 24 years old. Sis is half of Bubba plus 3. So sister is 15 years old. And then mom is 3 times sister. So 3 times sister plus 2. So mom is 47 years old. Inequalities now. When solving an inequality, you will solve it the exact same way as you do any other equals equation with one exception. If you ever multiply or divide by a negative, you must change the inequality symbol. That is the only rule you ever have to worry about. It's never what you're dividing into, it's only what you're dividing by. So this one, I'm subtracting 6. That does nothing to the inequality symbol. I am multiplying by 4. Now, the fact that I am multiplying to a negative does not matter. Multiplying both sides by 4 does not change the inequality symbol. Dividing by 3 does not change the inequality symbol. Now, here's how I always look at this, and you got to make sure to understand how to graph on a number line. -4, if there's an equal to line underneath, you'll make a solid dot. So I'm going to make a solid dot at -4. If there was no equal to line, you would put an open dot at -4. Now, the y is greater than the -4. Notice that the symbol, the bigger side, is closer to the variable. So the y value is bigger than -4, meaning all the values to the right are bigger and all the values to the left are smaller. Next one, I'm going to distribute. 8 minus 6z is greater than 22. Subtracting 8 does not change the inequality symbol. Here's dividing by a negative 6. Red flags, okay? Dividing by a negative changes the inequality symbol, and then 14 divided by negative 6 is negative 7/3, reducing. So now I go to negative 7/3. If you want to think of it as a mixed number, it's negative 2 1/3. So I'm going to put an open dot. I'm going to write in negative 7/3 right here. I'm going to put it open. The z, or the variable, is less than or smaller than negative 7/3. So I'm going to shade to the left. Sorry about my board there. There's supposed to be a negative 7/3. I'm going to try this again. Negative 7/3. Word problems. Tony is delivering boxes of paper to each floor on the office building. Each box weighs 64 pounds. Tony weighs 2 1/4. If the maximum capacity of the elevator is 2,000 pounds, how many boxes can Tony fit in the elevator? So what are we trying to find? Our x, or our variable, is boxes, number of boxes. So it's 64 pounds for each box, plus Tony, so 225. Tony's going to get in the elevator with the boxes. Must be less than or equal to 2,000. So again, the capacity inside, maximum capacity, is 2,000. Solving, so I'm going to subtract 225. So 64x is less than or equal to 1,775, and dividing by 64. So take 1,775 divided by 64. Your x is less than or equal to 27.73. Now, you got to think a little bit carefully here. Yes, x is less than 27.73 boxes. You're not going to cut a box in half. So this is the solution to the equation. In reality, you're allowed to put 27 boxes on the elevator. So you need both of these, the actual answer and what makes sense to the answer to the question. So x is less than or equal to 27.73, which means you can safely put on 27 boxes. You're not cutting a box in half. Your homework assignment, your first assignment of the year, is worksheet P.1. Good luck. If you have any questions, make sure you talk to your teacher.